Today we're going to be talking about graphing lines. And there's really two forms I want you guys to know. Slope-intercept form is the most common one. You guys probably dream about this one at home. Y equals mx plus b, where m is the slope and b is the y-intercept, where the graph hits the y-axis. And then there's standard form. Ax plus by equals c. And there's two ways to graph standard form. You could find the intercepts, or what you could do is you could put into y equals mx plus b if you wanted. And I'm going to show you guys both ways and show you that they get you the same graph. Our first example, graph that line. Now that's already in y equals mx plus b. So m is our slope of -2, b is our y-intercept of 4, so I go up to +4, and then I have a slope of down 2, but right 1, because I have to go negative and 1 to way positive. And I want at least 3 points. So if I go down 2, right 1, that's 2 points. Now something I want you guys to recognize, you could go up 2 and left 1. And that is our line. So that's not too bad. I kind of expect you guys to walk in knowing that. Graphing this line now. I'm going to show you guys two different ways. I'm first going to do the intercepts. X-intercept, Y-intercept. I make what you call an intercept chart. For the X-intercept, you make Y0. So if I make Y0, 3 times 0 is 0, that goes away. So now all I have to do is solve that equation to get 3. So I plot that point. Now, the y-intercept, you make x0. So you make the opposite variable of the intercept 0. So if I make x0, 4x goes away. I solve it, I get 4. And now 2 points make a line, so we just connect those. Solving for y equals mx plus b. 4x plus 3y equals 12. I subtract 4x over. Divide every term by 3. So I get the same y-intercept. If you count out your slope, you go down 4, right 3, we get to another point. Next example. Find the area of the region inside the circle and above the line y equals 1. Well, okay, here our center of our circle is 0, 0. Now be careful, the radius is the square root of 2. So here's 1, square root of 2 is a little bit above 1. So I'm going to put the 4 points down for my circle, just to get a general idea of what it looks like. And that looks like an alien head. And then, but above the line, y equals 1. So I draw on that line, y equals 1. Y equals is a straight horizontal line. Okay, so I'm looking for the area inside the circle, but above the line. So I'm looking for this area. So if I find the area of that sector, and I subtract the area of the triangle, that's going to help me out. So this is root 2, this is root 2, this is 1. Using the Pythagorean theorem, I can find that each one of those is 1, making this a right triangle. So this right here is a right triangle. So finding the area of the sector, that's 1/4 of a circle, pi, radius squared. So that's going to be 1/4 times pi times 2, or 2/4 pi, which is pi over 2. Now that's the area of the sector. I need to subtract the area of this triangle to get the blue region. So the area of the triangle is 1/2 the base, which is 2 units, times the height, which is 1 unit. So unit of 1. So our whole area is pi over 2 minus 1. Now again, I knew this was a right triangle because I knew this was 1, this was root 2. Using your Pythagorean theorem, you found this to be 1. So I knew this was an isosceles triangle. This was an isosceles right triangle. So I knew this angle was 45 and that angle was 45. So that's what you're going to find on the classwork. Here are your 3 lesson questions for the day.